In this module, we shall be able to understand the following 5 points. Number 1, understand the meaning and definition of applied psychometrics. Number 2, conceptualize measurement and its importance in scientific inquiry. Number 3, comprehend key principles of measurement in physical sciences. 4, understand how mathematics and measurement are related to each other. And finally, number 5, understand the need, importance and critics of measurement in psychology. Psychometric is the focal point of empirical psychological research and practice. It is the process of assigning values and numbers to represent the amount and kinds of specified behavior or attributes of an individual or group of individuals. Psychometrics concerned with the measurement of psychological attribute is totally concordant with the goals of measurement as defined by Stevens in 1951. Measurement as the assignment of numbers to objects according to some rule. Measurement has long been an important and permanent concept in the physical sciences and natural philosophy. Physical scientists have always been credited for the precision with which they are able to measure their constructs. More recently, the psychological sciences have developed a variety of techniques that purport to be instances of measurement as well. This module, which we are studying, is going to review the importance and the need of measurement in social sciences and advantages of standardized measurement over personal judgment and guessworks in psychological inquiries and research.
Let's start with the applied psychometrics concept, which is measuring the mind. We will start with the general definition of psychometry first. The term psychometry is etymologically derived from Greek meaning, which means measuring the mind. Klein defines psychometrics as psychometrics refers to all those aspects of psychology which are concerned with psychological testing, both the methods of testing and the substantive findings. It is a science of psychological assessment in which standardized measures are designed to measure psychological abilities and attributes of people. The field is concerned with the theory and technique of educational and psychological measurement, which includes the measurement of knowledge, abilities, attitudes and personality traits. The field is primarily concerned with the construction and validation of measurement instruments such as questionnaires, tests, inventories and personality assessments. Psychometricians use a specialized set of statistical tools to create scientifically valid assessments of various behaviors. These standardized measures are structured tests because they have a defined structure for administration procedures and scoring rules that are followed in the same manner by every professional who administers the test. Standardized assessments also have structured procedures for interpretation, which usually involves comparing the client's score to the score of a representative sample of people with similar characteristics. Let's understand some more definitions of psychometrics, from the most basic to the most professional and technical ones. Collins English Dictionary defines psychometrics as a branch of psychology which is concerned with the design and use of psychological tests. It is the application of statistical and mathematical techniques to psychological testing. In short, in Collins English Dictionary, psychometrics synonymously means psychological testing. Rustin Gollenberg defines psychometrics as the branch of psychology that deals with measurable factors. Another pioneer, Cronbach, refers to psychometrics as performance in number. The field is expressed in two famous old pronouncements: if a thing exists, it exists in some amount, and if it exists in the some amount, it can be measured. Thus, whatever exists in human ability traits, it exists in some amount and it can be measured with certain certainties. Seuss defines it as the science of developing educational and psychological tests. In terms of Seuss, measurement procedures has become highly sophisticated and has developed into such a large body of knowledge that it is considered a scientific discipline of inquiry in its own right. The discipline is referred to as psychometrics. MacDonald refers to psychometric theory as test theory in an abbreviated expression for theory of psychological tests and measurements, which in turn can be abbreviated back to psychometric theory, which is psychological measurement. Last but not the least, Miles has also defined psychometrics as the branch of psychology which is concerned with studying and using measurement techniques. What is common in all the definitions that we have studied just now is the measurement. So, before further moving, now let's conceptualize measurement. The definitions that we just read and discussed is clear that psychometrics is totally concordant with the goals of measurement. It is concerned with the measurement of psychological attributes. Understanding measurement from this perspective is important. Measurement in itself has been long an important and prominent concept in the physical sciences and natural philosophy. More recently, the psychological sciences have developed a variety of techniques that purport to be instances of measurement as well. However, scholars have also argued on the ways with which measurement in physical sciences and social sciences corroborate and differ. The body of work seems to suggest that the way in which measurement is understood by physical scientists and philosophers of science, and by the criteria of the latter group, there may not have been any instances of successful measurement of psychological attributes, or at least no such instances that it can be described in a philosophically coherent manner. So, it is essential to have conceptual understanding of the term measurement and its role in scientific inquiry. Let's formally define measurement first. Michel described measurement as a procedure for identifying values of quantitative variables through their numerical relationships to the other values. The most commonly applied definition of measurement is given by Stevens. According to Stevens, measurement is the assignment of numbers to objects according to some rule. However, this definition contains some inherent assumptions like things or attributes always exist in some amount, and whatever exists in some amount can be quantified and measured. This we discussed in the definition above also. The attributes are quantified in measurement according to a set of rules or criteria known as rules of measurement. So, measurement simply consists of rules for assigning numbers to objects to represent quantities of attribute. Students, looking at the definition of measurement, it can be emphasized that numbers are used to represent quantities. Quantification concerns how much of an attribute is present in an object. Numbers are used to communicate the amount. Quantification is so intimately interwoven with the concept of measurement that the two terms are often used interchangeably. Further, the definition also emphasizes that rules for quantification are at the heart of measurement. In establishing rules for the employment of a particular measure, the crucial consideration is that there must be a set of rules that is unambiguous. Thus, any set of rules that unambiguously quantifies properties of objects constitutes a legitimate measure of scientific usefulness. Let's see how measurement is an essential element of scientific inquiry. The importance of measurement in science cannot be denied. Standardized measures lead to the development of scientific knowledge, which is objective, exact, and verifiable. To note the advantages of measurement or standardized measures, it is necessary to compare them with what would be left if they were not available. Let's give an example. If there were no measures of light, height, weight, and temperature, we would be left with subjective appraisals, personal judgments, or whatever one would call the intuitive process involved. The major advantage of measurement is that it takes the guesswork out of scientific observation. The aim of a scientist or researcher in any scientific inquiry is to collect facts about an object or a phenomenon under investigation, objectively and precisely. These facts are not observed or considered in isolation from one another. Rather, an attempt is usually made to identify the nature of exact relationship among them, to interpret and formulate deductive or probable explanation of the object or the system or the events, whatever is there under the study. In order to ascertain the extent, dimension, or magnitude of something, or to determine the attribute of something with precision, scientists so often resort to measurement. This helps them to obtain quantitative data or information about object, phenomena, system, or their attributes. The quantitative data or information which accrues through measurement is more precise and meaningful than non-quantitative data or information that is generally vague and quite often misleading. Through measurement and quantification, with the aid of mathematical models and statistics, the scientists are able to distinguish objects or their properties and predicate or establish relationship among them with a greater degree of refinement and exactness. Thus, measurement is one of the essential elements of any scientific investigation and discovery. How measurement is different from mathematics? Are they synonyms or is there some difference between them? Let's see what is measurement and how it is related to mathematics. Mathematics is the formal, logical, and systematic structure with the help of which scientists formulates formal models to represent and measure objects, phenomena, systems or their properties, as well as their relationship to the empirical world according to some set of rules. Mathematical systems are purely deductive, being set of rules for the manipulation of symbols. Symbols for quantities constitute only one type of symbol found in mathematics, and much of modern mathematics concern deductive systems whose symbol do not relate to numbers. In contrast to mathematics, measurement always concerns numbers, and the legitimacy of any system of measurement is determined by empirical data. Measurement always concerns how much of an attribute is present, which requires a numerical statement of the amount. Measurement concerns the real world in terms of purposes, operations, and validity. The purpose is to quantify the attributes of real objects or persons. The operations concern doing something to obtain measurements. The validity or usefulness of a measure always depends on the characteristics of our empirical data. If a measure is intended to fit in a set of axioms for a measurement, the closeness of a fit can be determined only by the extent to which relations in empirical data meet the requirements of the model. Regardless of the character of the model, or even if there is no formal model, the eventual and crucial test of any measure is the extent to which it has explanatory power in its relation with other variable. The concepts of measurement and mathematics are so closely interrelated that the two often creates confusion. Both measurement and mathematics involve number and quantification. In the beginning, the concept of measurement and the mathematics were so closely bound together that no one considered the two as distinct disciplines. However, in recent times, mathematics and measurement are no longer considered tightly interwoven. Although measurement borrows its model from mathematics, it has become clear that the formal system of mathematics is empty play of symbols and constitutes a game of signs and rules having no reference to empirical objects or events. On the other hand, the process of measurement is concerned with systematic association of numbers or other mathematical concepts such as vectors for scaling or representing empirical attributes or relations in such a way that the value of the attributes or relations are faithfully scaled or represented as numerical values. The two disciplines can be looked as two-faced bipartite endeavors looking towards the formal, analytical, schematic feature of model building and toward the concrete empirical and experimental observation by which we test the usefulness of a particular representation. Let's now consider how measurement in physical sciences is different from measurement in psychological sciences. In this regard, we will first consider measurement in physical sciences. Physical scientists have always been credited for the precision with which they are able to measure their constructs. Rules and procedures for assigning numbers to the construct being measured are explicitly formulated in physical science. Consider examples of measuring the temperature, speed, height, weight, luminance, pressure, color of a given substance. The instruments that have been designed to measure such constructs have been built to be reliable and are usually calibrated on a regular basis to ensure the accuracy of values that they produce. What should be done is intuitively obvious, and consequently it is not necessary to study a thick manual of rules before undertaking the measurement. As long as the individual using the instrument knows how to use it and knows how to interpret the values, there is no problem in the measurement aspect of work. What are the two key principles on which measurement in physical sciences rest upon? Measurement in physical sciences rests upon two major principles. The first is objectivity, which means that any fact made by one scientist should be independently verifiable by other scientists. Measures in physical sciences are said to be well standardized. Formulating explicit rules for the assignment of numbers is major aspect of standardization of measure. Different people who employ the measure obtain very similar result. Thus, a measure of the distance between Earth and Sun or Earth and Moon in the solar system is well standardized if different astronomers measure them on one or two different occasions. The numerical values that they will be obtaining by various other techniques will be similar. The second key principle of measurement in physical sciences is quantification, that concerns with the quantity of an attribute or object. In other words, it is assigning numbers to represent quantities. These numerical indices make it possible to report results in finer detail than would be the case with personal judgment. Quantification permits the use of powerful methods of mathematical analysis. This is essential in the elaboration of theories and in the analysis of experiments. As you have now discussed and studied how measurement is done in physical sciences, let's contrast it with the measurement in psychology. The science of measurement was earlier a concern of physical scientists, and it was thought that only empirical objects or their physical properties can be measured. As Peter Cause pointed out, there seems to be a general feeling that no physical property can really quantify as such unless we know how to measure it. That is, unless we know how to describe situation in mathematical terms. It was considered that sociological and psychological traits, being abstract, not physical in nature, are more qualitative in nature and thus are not amenable to measurement. However, in the recent past, efforts have been made by psychologists to measure psychological traits through statistical and mathematical manipulation. Further, by acceptance and application of scales and measurement methodology developed by psychologists in the other fields of social sciences, one of the major obstacles hindering the study of social systems or phenomena on scientific lines was removed. Let's now see the need and importance of measurement in psychology. The importance of measurement in psychology cannot be denied. The major advantage of measuring psychological attributes is that it takes personal judgments and guessworks out of empirical investigation. The numerical results provided by standardized psychological measures helps to identify and quantify psychological differences that exist between people over time or across situations. Though construction and standardization of psychological measures require a great deal of effort, but once developed, they frequently are much more economical of time and money than our subjective evaluations. Besides saving time and money, standardized measures help in efficient communication among psychologists. Each psychologist builds on what has been learned in the past and day by day compares the findings with those of other psychologists working on the same types of problems. Communication is greatly facilitated when standardized measures are available. Suppose, for example, in an experiment concerning the effects of psychotherapy on depression, it is reported that in a particular therapy made the subjects appear better. This would arise hopes as to what the experiment mean by appear better, and consequently it would be very difficult for other experimenters to investigate the same effects. Much better communication would be achieved if standardized measures of depression were available and used. If statistically means and standard deviations of scores for the different treatment groups were reported, very efficient and precise communication with other researchers would be possible. Even if subjective evaluations of experimental results are very carefully done, they are much more difficult to communicate than our statistical analysis of standardized measures. The rate of progress in psychological research in a particular area would be limited by the efficiency and fidelity with which researchers can communicate their results to one another. Besides having widespread acceptance of measurement in psychology, criticism of measurement is also there. Let's see some of the criticisms of measurement in psychology. Despite the overwhelming interest in the concept of psychometrics, it is not without its critiques. According to Michel, it is concluded that psychometrics is pathology of science, and further adds the way in which psychometrics is currently typically taught actually subverts the scientific method. In comparison to physical scientists, social scientists deal with measurement of ambiguous constructs such as personality, attitude, leadership, emotional intelligence, creativity, anxiety, fear, etc. Certainly, rules for measuring psychological attributes are not intuitively obvious. Formulating explicit rules for the assignment of numbers is a major challenge of psychological standardized measures. Not only is there disagreement on how these are measured, but also in many cases there is no overall agreement on what is meant by the construct itself. In summarizing, we can say that social scientists mainly battle on two fronts in the field of psychometrics. The first obstacle that psychologists confronts when preparing to measure a psychological attribute is to be absolutely clear about what it is that one wants to measure. This is called the conceptual definition of construct. It means that if he wishes to develop a test that aims to measure the creativity, he needs to have conceptual definition of creativity on the basis of theoretical knowledge. Only then he would be successful in constructing a standardized measure for it. Another hurdle that social scientists face is the issue of accurate representation of the construct. In other terms, it means translating the conceptual definition into an operational definition. In terms of psychometry, this usually means creating items to assess the construct on the basis of identified variables of the construct. This requires a careful and methodical work on the part of social scientists. Students, let's summarize what we have discussed in this module. We started with the term psychometry and its meaning, which in short means measuring the mind. We discussed that the field of psychometrics is primarily concerned with the measurement of psychological attributes with the construction and validation of measurement instruments like inventories, questionnaires, tests, and assessments. Psychometrics is in agreement with the goals of measurement. We discussed measurement as a procedure for identifying values of quantitative variables through their numerical relationships to other values. Through measurement and with the aid of mathematical model and statistics, the physical scientists are able to distinguish objects or their properties and predicate or establish relationship amongst them with a greater degree of refinement and exactness. We also studied objectivity and quantification as the two major principles of measurement in physical sciences. Then we talked about measurement in psychology, which is based on the doctrine of measurement of physical sciences. Psychologists measure sociological and psychological traits through statistical and mathematical manipulations. The major advantage of measuring psychological attributes is that it takes the personal judgments and guesswork out of empirical investigation. Last, we discussed that the field is being questioned whether numbers are eligible and capable enough to denote all the psychological attributes. Thank you. Now let us look at the meaning of psychometrics at a much deeper level. The term is derived from a Greek word meaning measuring the mind. It is the science of psychological assessment in which standardized measures are designed to measure psychological abilities and attributes of people. Psychometricians use a specialized set of statistical tools to create scientifically valid assessments of various behaviors. Measurement has long been an important and prominent concept in the physical sciences and natural philosophy. Its definition varies. For instance, Michel described measurement as a procedure for identifying values of quantitative variables through their numerical relationships to other values. This definition is quite distinct from the definition of measurement proposed by S.S. Stevens. Measurement is an essential element of scientific inquiry, as the standardized measures lead to the development of scientific knowledge which is objective, exact, and verifiable. Comparing mathematics and measurement, it can be said that measurement concerns numbers. It is concerned with how much an attribute is present, whereas mathematical systems are purely deductive, sets of rules for the manipulation of symbols. Measurement in physical sciences rests on two major principles. The first key principle of measurement in physical sciences is objectivity, which means that any fact made by one scientist should be independently verifiable by other scientists. The second key principle of measurement is quantification, which concerns with quantity of an attribute or object. In other words, it is assigning numbers to represent quantities. The importance of measurement in psychology cannot be denied. The major advantage of measuring psychological attributes is that it takes the personal judgments and guessworks out of empirical investigation, and once developed, they frequently are much more economical of time and money than are subjective evaluations. But psychometrics is not far away from criticism. In comparison to physical scientists, social scientists deal with measurement of ambiguous constructs such as personality, attitude, leadership, emotional intelligence, creativity, anxiety, fear, etc. Rules for measuring such ambiguous psychological attributes are not intuitively obvious. Also, an overall agreement on the conceptual definition of the construct is difficult to attain for psychological constructs. In this module, you have learnt about the field of psychometrics, which is primarily concerned with the measurement of psychological attributes with measuring instruments such as questionnaires, tests, and personality assessments. Measurement is a procedure for identifying values of quantitative variables through their numerical relationships to other values. Through measurement and with the aid of mathematical models and statistics, the physical scientists are able to distinguish objects or their properties and predict or establish relationship amongst them with a greater degree of refinement and exactness. Objectivity and quantification are two major principles of measurement in physical sciences. Measurement in psychology is based on the doctrine of measurement of physical sciences. Psychologists measure psychological traits and attributes through statistical and mathematical operations.